Okay. Can you all hear me all right? Okay, good. I'm glad to be here. Thanks for inviting me. It's a terrific symposium, and Santa Barbara's just great, and everybody is too. And I hate to disappoint people, I'm not going to use the word sex at all in this talk. So we heard some about Clovis, so I'm going to give you a little bit more about Clovis and perhaps a different perspective about Clovis. But first off, I just want to go ahead and I want to start off with Clovis, move to pre-Clovis, and the evidence for pre-Clovis sites, and then try to tie things together as best we can. And so if you ask an archaeologist what is Clovis, and he'd probably tell you it's an archaeological complex. And what that is, it just means that it's a very distinctive set of tools that were made in a very prescribed way. And Clovis, you know, had different technologies. They had biface technology. What they would do is go out and seek excellent raw materials such as chert and chalcedony, such as this Edwards chert here. They would bifacially reduce it, reducing it on both sides, you know, and trying to produce the end point here, which is the classic lancelet fluted spear point. Also, they made ovate bifaces as well. Also, too, Clovis had blade technology. They had specially prepared cores, such as this one, that they would take long, slender flakes off that we call blades. They would snap those blades and use them without modification. In some cases, they would modify the ends, turning them into end scrapers. They would serrate them. They would turn them into drill tips, etc. So they were, you know, basically the Swiss Army knife of its day. In addition to that, they had osseous technology. They had these bi-beveled bone rods that were uncertain as what they were used for, but they also had these pointed projectile points in Clovis assemblages. So how old is Clovis? Okay, well, really there's only 13 well-dated Clovis sites scattered across the United States. And they range from the eastern seaboard over here to the edge of the Rocky Mountains, pretty much. We don't have anything over here. And by well-dated, I mean there's multiple ages, reliable materials. There's an additional 9 sites that also have single ages, and all these ages fall between 13,000 and 12,600 calendar years BP, or 400 years, okay? Now, there's 2 sites that have older ages, one which was just published called the El Fin de Mundo site, in which there was a gomphothere associated with the Clovis spear points and a few other artifacts. And a single piece of dispersed charcoal on that surface gave an age of about 13,500 calendar years BP. And if that were a pre-Clovis site, that dated 15,000 years ago, people would be screaming up and down saying that that's not a correct age because, you know, one age, you know, is you only have 2 chances in 3 that's the correct age, and it's not even, and it's a dispersed piece of charcoal. Also, there's only 2 other ages that are old, and those come from the Aubrey site, and essentially they need to be reconfirmed, but that's just not happening. Okay, so the next question is where is Clovis found and where did Clovis originate? Okay, if you look up in Siberia, we don't find Clovis. We don't find those artifacts that I just talked to you about. If you go to Alaska, you don't find Clovis. You don't find Clovis artifacts there. But you do find, you know, lancelet projectile points. They're typically made on flakes, deep bases, but they have multiple flutes. And for many years, you know, they were found, especially up here in the northern part of Alaska. People wondered how old those were. Were they proto-Clovis? Were they even super early Clovis? Were they after the Clovis time period? Nobody really knew. And Ted Gable worked out here on the Stewart Peninsula at a site known as Serpentine Hot Springs, and it was a lust deposit, and he found cultural features there and got radiocarbon dates that showed that these artifacts date, you know, roughly 12,000 to 12,400 calendar years BP. In other words, they postdate the Clovis time period. And then that was subsequently confirmed by work at the Raven Bluff site. Okay, go down to South America. Do we find Clovis down in South America? No, we don't find Clovis in South America. You know, there are sites that are the same age as Clovis along the Pacific coast and down here in the southern cone. They're typically associated with simple unifacial type artifacts. A little bit of bifacial stuff here, probably the preforms for perhaps fishtail projectile points. Where Clovis is found is right here, basically south of Canada, you know, in the United States pretty much, extending into northern Mexico. But once you get down into Mexico City in the basin of Mexico, you don't find Clovis. In the basin of Mexico, not a single Clovis projectile point has ever been found. Okay, so that's where we find Clovis. So, you know, very clearly, I think what this evidence is telling us is that Clovis originated somewhere south of those continental ice sheets and that people must have been here before Clovis. Before we move on and talk about those early people and the evidence for them, let's talk about who is Clovis, or basically who were the first Americans. And Eska Willerslev talked about this. And there was one Clovis burial found here in 1968 at the Anzac site in less than ideal conditions. It was found by a front end loader. And this was a Clovis burial, and it dates, the bones themselves date to about 12,700 calendar years ago, found right down here at the base of this sandstone cliff. The skeleton was that of a male about 1 to 1.5 years old, a small child. It had grave goods. It had 100 lithic artifacts with it. You know, Clovis projectile points and bifaces, and 15 osseous artifacts, these rods. And everything, the bones and all these tools were covered in red ochre, just ochre on everything. Well, the DNA analysis showed, as Eska was talking about earlier, you know, that basically Anzac and Clovis is directly ancestral to modern Native Americans, you know, especially those living in Mexico and to the south. And as Dr. Willerslev mentioned, you know, a cousin relationship to those people living to the north. The first Americans, Clovis, and Native American populations seemed to be derived from a single source population, and we've talked a lot about this Brin G and standstill hypothesis. And clearly these people came from Asia. So once and for all, this just, you know, puts the last nail. Dr. Meltzer's been working for years talking about there's this idea of the Solutrean hypothesis that Bruce Bradley and Dennis Stanford proposed, and he and others, and Ted Gable and others have been pointing out that from archaeological evidence, this idea that people came from Europe made no sense and gave rise to Clovis. And genetically now we can actually prove that. Well, you know, as Eska mentioned, you know, with the genetic evidence, it indicated that people were here before Clovis. And surely from that archaeological evidence, you saw that people were occupying South America at the same time as Clovis, and that people must have been here before Clovis. But how much earlier? Well, there's some good evidence out there. Some really solid evidence occurred in the 1980s, and that was the work done by Tom Dillahay at Monteverde, showed that people were living at the southern tip of South America by 14,400 years ago. Jim Ottavazio up here at Meadowcroft Rock Shelter has been talking since the 70s about finding what he calls the Miller Point and bladelets from Meadowcroft Rock Shelter. I think two unsung heroes of first Americans archaeology are these two sites in Wisconsin, the Schaefer site and the Heber site. These were original dates from these sites were incorrect. You know, Tom Hyam was talking about radiocarbon dating and accuracy, and these were dating to the Clovis time period, so they got included in Clovis date lists. But when these were redated, using highly purified bone collagen as well as wood samples, the Schaefer site dates to 14,200, the Heber site dated to 14,800 calendar years before present. All associated with artifacts, 2 bifaces and 3 other artifacts at Heber, and at Schaefer there were 2 flakes. And there's something like 25 radiocarbon ages from Schaefer. Of course, we heard about Paisley Caves already, where we had the coprolites, you know, that Dennis Jenkins found, analyzed again by Dr. Willerslev here at 14,100 years ago. But now what I want to do is kind of fill in a few more sites out there that we've been investigating over the years. And the first one I want to take you to is this one, the Deborah L. Friedkin site. And this site is located in central Texas, just kind of north of Austin. And this is Buttermilk Creek right here, and it's right in the headwater areas of this little tiny creek. It's a nice spring-fed creek right here. The Galt site's located here. This is the site that Mike Collins has been investigating, just a large Clovis locality. And just downstream of this is the Friedkin site, where we've been working since 2006, and we've excavated about 65 square meters there, and this appears to be a camp or activity site. At this site, when we were excavating here, we found 60 diagnostic artifacts, and they were all in correct stratigraphic order. So up at the top, we found late prehistoric, projectile points, typical late archaic projectile points for central Texas, kind of a slowdown in deposition, not too much middle archaic material. Found a lot of early and archaic and late Paleo-Indian material, these Wells points and Angosturas in this zone. In this zone, we found late Paleo-Indian Golandrina and Dalton, as they call it. In this zone right in here, which would be the Younger Dryas, we found Folsom and Midland artifacts. Down in here, in a layer about 2.5 centimeters, we found Clovis bifaces and blades with overface flaking on them. And we were surprised as we kept digging down, we kept finding more and more artifacts until we hit a certain point where we really didn't find artifacts anymore. So we were really curious about this, and we kept digging and digging and digging to try to convince ourselves or figure out whether that material was in place or not in context. We eventually convinced ourselves that that material was in place. We called it the Buttermilk Creek Complex, and it consists of over 16,000 artifacts. There's over 55 tools now. We have bifaces here, and this one's been broken. We have larger kind of bifaces that have chopping marks on them. We have discoidal cores and flakes that come from discoidal cores. We have expedient tools such as this concave scraper, pointed piece, this little unifacial tools, this little bifacial tool here. We have red ochre that's been ground. And we also found blades and bladelet segments. And then we also found a lot of radially broken or bend broken tools here. Here's a biface that was snapped, and then here's a flake that has been snapped multiple times. And we were talking about this on the field trip. Now, we found a lot of these in the older levels, this Buttermilk Creek levels, and some in the Clovis and a few in the Folsom levels. And when we looked at these, we found that they were heavily used as much as a Clovis end scraper. What these are push planes, and just great for working bone as well as antler. Well, we wanted to determine the age of this archaeological site, and unfortunately there was nothing to radiocarbon date. We tried the bone, there was no charcoal. Tom Stafford was out there once and he told me, he says there's more carbon in my knife blade than there is in this whole site. And so we turned to using the OSL or luminescence dating technique, and Steve Foreman came in and did that. He was at the University of Illinois up in Chicago at the time. Now he's down at Waco, so another Texan now. And so we did a column of luminescence samples, and when we got these samples, they came back all in stratigraphic order, and they correlated with the archaeological horizons quite nicely. And Steve told me, he says, well, nobody's going to believe this. And I said, yeah. And he says, we know we got to do this again. And I said, yeah. And so what we did is he came back the next year, and we did closer in spacing and horizontal spacing to get even more luminescence ages, and we reconfirmed the original column. OSL, for those who don't know, it's been used in geology for the last 30 years quite effectively. It's best for dating wind-blown aeolian sediments, and it turns out that what we're dating is quartz and feldspar within these floodplain deposits, and that's aeolian grains, and they've been blown in from West Texas. So we know that. Well, what we did is we continued to say dating this Buttermilk Creek complex, and we found out that it dated roughly around 13,000 to maybe upwards of 15,500 years ago. Now, there's been some questions, are these artifacts in place? Okay, there have been some people who suggested the material's moving up and down. Okay, well, we have 60 diagnostic artifacts that are in stratigraphic order. We have technologies where they ought to occur. Like, for example, all the fluting flakes that we get occur in the Clovis horizon and up here into the Folsom horizon only. None are found above, none are found below. As I say, we have 60 dates in correct stratigraphic order, and they correlate across the stratigraphy where we did find them. The dates tend to correlate with the known ages of the Paleo-Indian occupations and archaic occupations. We have technological refits with flakes fitting on flakes. We've done 2 magnetic studies throughout here, and there's no magnetic anomalies that we have. In other words, it's just a nice decline in magnetic signal. We've done extensive work on the soil properties, again indicating nothing's moving around. We're going to hear Jim Kennett tonight talk about his idea that there was a Clovis comet. And so I just gave him some samples, and one of the things that's a marker of that are these, quote, hexagonal diamonds. And I'm not saying it's a comet necessarily. I'm just saying that we sent him some samples blindly, and he found this marker horizon about right here where it should be, without nanodiamonds moving up and down. And the other thing we could do is we could correlate the geology to the channel margin sequence. In other words, whenever there was channel downcutting in the channel, there was very slow deposition on the floodplain. Whenever there's rapid sedimentation, there was, here on the floodplain, there's rapid sedimentation on the, rapid sedimentation occurring in the channel and channel margin. And of course, we found no artifacts down here in the lower levels that were dating upwards of 32,000 years ago. And then the sequence has also been reconfirmed at the Gault site. I want to take you to another site, and that's the Mammoth site up here in Washington. And this is a really interesting locality that was investigated by a guy named Carl Gustafson. He was at Washington State University, and he investigated this site from 77 to 79. And what he found is right here on the Olympic Peninsula, about right in here, he found the remains of a single mastodon in a kettle. And that's just a small glacial pond. And he excavated this, and this mastodon was laid on its left side, and the right side had been butchered with the bones moved upslope and kind of stacked on the upslope side. The key artifact he found was this, and that was a rib. He didn't find any stone tools, but he found this rib of the mastodon with this thing sticking in it. So he suggested what this might be. He had kind of a fuzzy X-ray at the time, that this might be the tip end of a bone projectile point embedded into this rib. He obtained radiocarbon samples below the Mazama ash here that indicated that this was maybe around 12,000 calendar years BP. Or 12,000 radiocarbon years BP, or about 14,000 years ago. Well, a lot of people didn't believe this. The dates were bad. This wasn't good enough evidence. Gary Haynes even suggested that maybe it was an angry elk that had taken out after this mastodon and gored it, and it was a tip end of an antler. And so this site has always intrigued me. So I called Carl up, and I said to him, do you still have that? And he said, yeah. And I said, well, can I look at it and investigate it? And he said, sure. So he just sent it to me. And so the first thing I did is I got it identified, and we figured out it was the 19th rib on the right side, because we wanted to make sure it was a shot that really could be made. Not covered up by the scapula and not covered up by the articulated end. So the next thing that we wanted to do is find out what did this thing look like on the inside, because now we got better technologies, okay? So we did CT scanning at the industrial level. Over at the University of Texas at Austin, they have an industrial grade CT scanner where the CT scans are about the width of a piece of paper. So they CT scan this about 380 scans across the width of this rib, and when they did this, they produced these high-resolution X-ray images. And so this is the exterior of the bone. This is this piece sticking up right in here, and you can see this sticks in here quite deeply, about 2.5 centimeters in all. And this is a close-up of that too. But because those slices are so close to one another, they can do a 3D rendering. And so they did this 3D rendering, and you can clearly see this object coming in, being shaped to a tip, breaking off at the tip, and the actual piece kind of scissoring as it went into this elephant. Well, I think this is clearly, as Carl said, the tip end of a bone projectile point. Next thing we did is we radiocarbon dated the rib itself as well as other bones. I've got about 4 radiocarbon ages. They all came out about this, giving a calibrated age of 13,800 calendar years BP. Looking at the thickness of the hide and whatnot and the skin to get to this point would have been about maybe 25, 30 centimeters in length, the tissue that it had to penetrate through. And that was about the length of this bone projectile point that was found at Sheridan Cave that dates to the Clovis time period. So again, a very, very interesting locality. Another one I want to take you to is this one right here. We've been working out at the Ladson site for the last 3 years. And again, this was a site that was found many, many years ago. There was the Osceola River Project being headed up by a fellow by the name of David Webb. And Jim Dunbar, a very well-known Florida archaeologist, was working with him. And they were working along the Osceola River from '83 to 1997. And working at many sites, finding many sites, investigating them. And they spent a lot of time here at the Page Ladson site. And one of the things they did is they excavated large blocks. This is underwater, by the way. So this is a sinkhole that's underwater right now. And you may ask yourself, well, wait a minute, how do artifacts get underwater? Well, you got to remember that during the Pleistocene, late Pleistocene, sea level was lower. So as a consequence, these sinks would have been, devoid of water, and there would have been freshwater pond at the bottom of these sinks. So you could just walk right down into these things along the colluvial slopes. So in their excavations, what they did is they defined quite a nice stratigraphy here, and well-dated stratigraphy based on radiocarbon dating of twigs and seeds. And down here in this lower unit 3, which dated around 14,400 years ago, they found artifacts, about 6 or 7 of these, and they also found this tusk that had cut marks on it. So they presented all this evidence, and everybody said, well, it was an underwater site, and probably because there's this, late, early archaic kind of Bolin layer up here, maybe Bolin artifacts fell down in there, when you weren't looking, and that's what you found, okay? So, and that's where that's where it ended. So one day I was in my office, and Mr. Ladson called me up, he's a landowner. He says, if you want to come investigate this site, you can. And I went, holy cow. He says, just come on out here to Florida and talk to me. And I said, okay. And I was very fortunate because at the time I had a great graduate student named Jesse Halligan, who's now graduating and teaching at University of Wisconsin La Crosse. And she'd been working along the Osceola River on some other sinks. And I said, how would you like a postdoc? And I cobbled together some money to do this. And I said, let's investigate the Page Ladson site. And she said, yeah, I'm not an underwater archaeologist. She is. Although I did my first scuba dive there. And fortunately, they had a wetsuit big enough for me. Never done it before. And I have newfound respect for people working underwater. Because after you go down about 6 feet, it went pitch black. And then until we got down there, and it was all lit up with lights. And it was cold down there, too. So the first year we excavated over here close to where they found material before. We didn't get any artifacts. But we did find more of the Mastodon. So the next year I said, okay, we got to try one more time. Let's give it a go. And so we excavated this area in green. And when we did this, we found this biface, okay? And it wasn't found, it was found during the excavation. You dig with trowels underwater, just like anywhere, and like you do on the land. And so we sent divers down. Morgan Smith and John went down, and they were starting a new level and excavating, and they went down about 4 centimeters and then clinged with their trowel, and they looked, and it was a biface. And so Morgan comes shooting up to the surface, saying they found a biface. Jessie, immediately just throws on her wetsuit and tank and goes down there, and confirms that it is a biface. So what we do, just to make sure we don't end up in a situation where we don't have, excellent dating, we immediately collected twigs all around this thing, on top of it, on the bottom of it. We dated those, and they came out 12,450 plus or minus 20 radiocarbon years BP, or about 14,400 calendar years BP. We since now have about 50 radiocarbon ages. We did it a stratigraphic column all the way from the base of Unit 4 through Unit 3 and below at every 2.5 centimeter level, and don't have a single date reversal, again confirming the age of this biface. We went back there this summer, got a bonus. We got another artifact down here, and we also found some additional artifacts in the lower portion of Unit 4L as well. So again, one of these sites that we went back and looked at. Another one I want to take you to is up here in Canada to the site of Wallys Beach. And this is a really neat site area. And it was investigated by Brian Koeman and his colleagues. It's located right here at the right at the almost the border with Montana up in Canada. And around, in this area, he has some windblown sands. And in the windblown sands, he found 8 horse kills. He found here's the vertebral column here. Here's a big stone here. There's some artifacts associated with it. And there's artifacts with every single horse. And there was a camel kill there. And you can see the vertebra, and you can see the ribs just kind of broken off from the vertebra there. And again, associated with the artifacts. Here's an artifact here, or here's one here. But the artifacts that were there were these, like this little core tool, this chopper, this bifaces, and flakes. Well, the dates that Brian had gotten and reported were 11,000 radiocarbon years BP. And that made them 13,000, so they got called Clovis. Well, I realized that those things were just unpurified bone collagen. So I called Brian up and I said, Brian, how about we date all those horses and that camel again? And he says, yeah, let's do it. And so we now have 25 radiocarbon ages that show that the horses date to 11,450 plus or minus 10 radiocarbon years BP when you average them together, and the horse 11,440 plus or minus 25 radiocarbon years BP, or about 13,300 calendar years before present. And what's really neat, too, at this site, it's kind of a place that's a really nice trackway. And all these kills are found in a real small area. I mean, just a very compact area. And so this probably represents hunting of these animals in a very short period of time, maybe a week, maybe a month, maybe a short season, and as they were trying to go across the river and come up to the other side. Moving on, I just want to point out this site, the Lindsey Mammoth site. This is a really interesting site, again, where the radiocarbon dates led people astray. And again, Tom's absolutely right, because, you have to have excellent dating. Without excellent dating, you don't have anything. I always tell my students that data and chronology are king. And if you control the chronology, you can actually, figure out what's going on. So at this, it's interesting, at this site, the Lindsey site in eastern Montana, it was excavated by Les Davis back in 1967. And if you go on the line, you can see an interesting movie, 8mm movie that he's transferred over of the excavation. They found a single disarticulated mammoth that was in a loess deposit. Loess is wind-blown silt. So, imagine just silt-sized grains being blown by the wind. The interesting thing about this site is he didn't find any stone tools with it, but he found 8 sandstone blocks, okay, in the loess. And you kind of wonder, well, how did sandstone blocks get in the loess? They didn't get blown there. I don't think they're gizzard stones. Maybe, and he made the case that there was humans, brought them up as anvils, because there was bone breakage and stacking at the site. Well, most recently, a study was done by one of Gary Haynes' students, and she found 15 unequivocal cut marks made on stone tools, by stone tools, on 4 of the bones from the Lindsey Mammoth. But however, the Lindsey Mammoth was classified as a Clovis site because of the radiocarbon dates. Wow, we looked at the radiocarbon numbers that were in there, and I said, holy cow, that, I wonder if that really truly is, 13,000 years old. And so I called up Jack Horner. He runs the Museum of the Rockies, and I said, Jack, can we have some of the Lindsey Mammoth, the radiocarbon date? And Jack said, yeah, you can have it. I don't care anything about mammoths. I like dinosaurs. And he said, I'll get my preparer to cut off as much as you want. I said, well, we need a little bit, And so what we did is we got a number of radiocarbon dates, and lo and behold, they came out 12,300 plus or minus 25 radiocarbon years BP. There's about 4 ages, or 12,450 calendar. So what's really interesting is, are there sites out there that don't have stone tools associated them, but can be identified through taphonomic processes? And that might be the case at a couple of other archaeological sites out there. So now if you look at this, you can clearly see there's quite a range of older sites. People were clearly in the Americas by 15,000 years ago. They were widespread, and they had bifacial technology. We got that here and over at the Friedkin site. They had bladelet and blade technology here and here. They had osseous technologies up here, and indicated maybe by those artifacts at the Friedkin site. All the things you would need to eventually become Clovis. I just want to digress for a minute and talk about extinctions in the context of what we know about these pre-clovis sites. Okay? All right, David talked about how, there was this large extinction. And what's really, I think, some of the most interesting work that's been done is proxy evidence by Jan Gill. And she looked at this. It's a dung fungus called Sporormiella, and this is what it looks like. And she used this as a proxy to track the extinctions of megafauna, or herbivores. And in two cores, one in New York and one in Indiana, she was able to track the Sporormiella concentrations and found that they remained relatively constant. And then all of a sudden, beginning around 14,800 years ago, those concentrations began to decline, with finally the Sporormiella disappearing completely at 12,700 calendar years BP from their cores. Wow, that's pretty interesting. Well, we're doing the same thing now with that. We collected a long core at Page Ladson, and we're doing the same thing, and we've been able to find Sporormiella in the Pleistocene segments of the cores, but not the Holocene segments of the cores, and we're moving like this to try to find out where those declines occur. Another site that will be done too is at Hall's Cave by Tom Stafford in Texas, so we hope to have 2 more of these kind of proxy curves. But what's really kind of interesting is when you start thinking about those sites that we just talked about. Heber site, 14.8. Page Ladson, we got a Mastodon, 14.4. Lindsey site, 14.2. Schaefer site, 14,200 years ago, another Mammoth here. Manus, 13,800 years ago with this Mastodon. Wallys Beach with the horse and the camel at 13.3. And then finally Clovis showing up on the scene, developing and deploying this weapon system out there, taking out probably the last of them, between this 13,000 and 12,700 years ago. Now, I'm not talking about blitzkrieg here, so don't get me wrong. I agree with David that with ecological changes, these animals were probably stressed. Gary Haynes points out that probably they became more easy to hunt, as you got here in the Clovis time periods, because they were hanging around fewer and fewer water holes, maybe easier to find by tracking them along trackways. But, this is just, it just kind of shows that there is a legacy of about 2,000 years of hunting taking place in North America. Now, I just want to try to put all this together, all the things that we've been talking about here. And I'm going to start with just the Brin G standstill model here, kind of try the geological evidence, the genetic evidence with the archaeological evidence. And we've heard a lot about the Brin G standstill hypothesis right in here, where this population stewed around, for about, from about 25,000 years ago to maybe 18,000 years ago. And this is where the signature of the first Americans was created, the genetic signature. About 2/3, as I say, East Asians, and about 1/3 Eurasian, as Esko was mentioning. They're ready to go at, 18,000 or so, okay? But they got a problem. They got ice, okay? There's ice right in here. The Laurentide ice sheet is making Brin G a huge cul-de-sac. How do you get out of this cul-de-sac here? You got this glacial ice here, okay? The first corridor that appears to open up is the coastal corridor around 16,000 years ago, okay? And that's when maybe people were able to come through here. The inland corridor, it looks like, opened up maybe around 14,000 years ago. May not have been the world's, best corridor to traverse at that time, but by 13,000 years ago, clearly the inland corridor was very viable, and people and animals could move in both directions. What about those sites I mentioned to you? Okay, you got the Friedkin site here at 15,000. You got Heber at 14,800, Meadowcroft at 14,400, Page Ladson at 14,400, Monteverde at 14,400, 14,200 here at the Schaefer site, 14,200 at Lindsey, 14,100 at Paisley, 13,800 at Manus. How do you get these people here? Well, they probably came along the coast, because they couldn't get through here because there was no inland corridor for them to go through. So more than likely, they came along the coast. That's the only way to get these people over here. And then finally, Clovis showing up on the scene roughly around 13,000 years ago. I'm not opposed to Clovis dating older than that. I just want to be convinced of it. You know, I have no problem if Clovis date's older than that. Now, you've often heard also too about older archaeological sites. You know, there's sites in Nebraska, Ladson. There's another one in Kansas called Lovewell, you know, where we have just, you know, what they thought were broken mammoth bones that were broken up. You got the Topper site that is supposed to date around 20 or 30,000 years old in South Carolina. You got Pedro Ferrada in Brazil, almost at 50,000 years ago, and Miles Point in Maryland, you know, dating 21,000 years ago. Well, if these sites are legitimate, people had to have come, you know, before the late glacial maximum, when this was the time when people could get through. And there was, again, an earlier ice-free corridor. But this doesn't square with the genetic evidence at all. So you're left with a couple of interpretations here. Either these aren't archaeological sites, which is probably the case with the Topper and definitely Pedro Ferrada and Ladson. But then here, look at Miles Point, it's got a projectile point. But maybe there's something wrong with the geology and the site formation processes that have not been investigated. Because this particular site, this material's just been plucked out of the sidewall and some dates gotten from the sidewall. You know, you need to excavate the site, study the geology, go down on it and understand it. The other thing is, any of these ever pan out to be real archaeological sites, then it probably just represents a failed migration in America, or people that, you know, didn't pass their genes on, you know, to modern living peoples. So in conclusion, what I'd just like to say is, you know, clearly the Americas were definitely populated, I think, by at least 15,000 years ago, maybe a little bit before that. And also, too, it's a pretty exciting time in First American Studies as we're formulating a new understanding of the people of the Americas, and there's differences of opinion, but as I say, that's what makes for horse races and makes the field exciting. So, and the greatest thing I think that's happened in this field is genetics, because now, you know, I think what's going to happen is the genetic evidence and the archaeological evidence are going to come together, and that'll give us a true story about the first Americans. Thank you.
Thank you, Mike. We will have to keep the questioning to fairly brief because we have one more speaker, and if you want to give a little time for questioning there also, we'll have to be short. But again, a very quick question first. So we do have that early migration, coastal migration, but many of those early dates come from fairly far inland. So you are presupposing a pretty rapid spread inland. Is that correct?
Yeah, it'd probably have to be pretty rapid spread inland. You know, they'd have to come along the coast and then move inland. I always say with the coastal migration that people come in, they'd see Washington and Oregon, they keep pushing south, they'd find San Francisco. That's nice. They'd find Santa Barbara and they'd stop. But yeah, that's you know. But there's a lot of continental shelf. It's submerged and it's hard to deal with.
Well, here's some questions that I think are going to get us into controversy. But let me just read this one. You mentioned nanodiamonds. Are there any other known mechanisms for creating these other than high energy impacts?
That'd be a great question for David Meltzer. You know, he and Vance Holliday have been trying to come up with alternative explanations for the nanodiamond marker horizon. Yeah. And as I say, there's arguments on both sides. And they argue about the precise dating and stratigraphic context of this material, and Jim Kennett and his colleagues have been working very hard to characterize the chemistry of these nanodiamonds and their characteristics and mineralogy. And so I think the verdict's out. We just have to be open-minded, and that's the thing right now, is just people have to be open-minded and think about this. But there might be other mechanisms to form nanodiamonds. You know, it's one of those things that just continues to be worked on and studied. In fact, what we're planning to do, Tom Stafford and I, at a cave site in in Texas is we're going to actually sample this sequence that dates back from 18,000 years to the Holocene and see if, you know, we can find nanodiamonds occurring in other stratigraphic levels, or see if it just falls in one particular spot. Because you need to test these things. That's the way of science. You get ideas out there, they're radical ideas, and it's just a give and take of science right now.
Question here about the relationship between pre-Clovis and Clovis.
Oh, okay. Yeah, in my opinion, well, I mean, the genetic evidence indicates that there was a single migration of people into the Americas, okay? And it's from that that, you know, all modern people were derived. And so I guess there's really there's no evidence of multiple migrations into the Americas. So if you have all these pre-Clovis people in the Americas from Florida to Wisconsin, you know, and they have biface technology and blades and bladelets, and they have osseous artifacts. Those are all the things that would eventually become, you know, would have to be the rudimentary technologies to become Clovis. But the $64,000 question is why? You know, why would this technology emerge all of a sudden? There had to be some sort of reason for it, but I don't know what it is, and only time will tell as we investigate more science.
Okay. And here's two related questions that I do want to ask, because they're very reasonable questions for non-archaeologists. And the first one is, how can you really tell a tool is Clovis? What is so special about them? And number two, has anybody ever tried to make Clovis points and experimentally recreate them?
Yeah. Okay, yeah. Clovis artifacts are very, very distinctive. You know, there's nothing like them. The classic Clovis projectile point has a lancelet shape with a slight concave base, single fluke coming up the middle. There's overface flaking that occurs across them, very distinctive flaking pattern. And when they're fairly robust, you know, not thin like a Folsom point that's also fluted, but fairly robust. And they tend to be fairly large points, but they can get reworked to quite, you know, a short length as well. And the blades and the blade cores and that were made, you know, again, you know, are only found in the Clovis time period that we know of right now. So the flaking techniques that were used and the types of artifacts that were made, you know, clearly will tell you that you're dealing with a Clovis site. Now that osseous material, that went on for a long time. You know, we find all the way from Mammoth, all the way through Clovis, and now they're finding that those beveled rods also occur in Folsom. There was a famous one that was found up in Canada, again dating, I think, the Folsom time period, maybe slightly later. So they tend to be a technology that continues on, and but Clovis is really, really distinctive when you do see it and you get used to seeing it. Very distinctive technology. And yes, people have replicated these things. There's a lot of replicators, both professional archaeologists and flint knappers and people that study lithic technology, and they make Clovis points, you know, just like prehistoric people do. But there was an interesting study done where they looked at an analysis, a morphometric analysis on these points, and looked at the flaking patterns. And they said that at least Dana Stanford and Bruce Bradley claimed that you could tell the difference between modern knappers and prehistoric knappers. But I don't know if that's
okay,
true.
Thank you very much, Mike. I'm afraid it's the only time we have for questions. We do need to move on. Next speaker.